Okay. So I'm going to really quickly cover the topic of Cartesian product. It should take like 3 minutes. It's not a central focus. I want to get on to other more crucial things. So what the heck is a Cartesian product? Well, the main example of this with which you should be familiar is the XY plane, which is formerly known as the Cartesian plane, named after René Descartes, who contributed a lot to the mathematics behind it. So, for example, when you name a point and you give the two values, the x value and then the y value, generally speaking, in our basic example, we think of x as a real number and y as a real number. So what we're really starting with when we think first of just x by itself. How would you represent x? First of all, you'd say x is a real number, and you could say x is on the real number line. And by the way, that fancy R is math notation for real numbers, with the double bar. Okay. So now we're going to introduce some of the notation that we're learning this semester. So we used to just say x is a real number, y is a real number, or such, but we actually now know how to say this in set notation. If you think of R as, instead of just calling it real numbers, if R is the set of real numbers, and you want to say x is a real number, how do we say that in set notation? X is an element of R. R is like the collection or the set of all real numbers, and x is one of them. So a lot of times in fancy notation, you'll see something like this written down. You may or may not have seen it before, but this is actually what it means. I would just read this as, formally, x is an element of R. Informally, x is a real number. So y is a real number as well. But let's get back. So that's sort of bringing around the stuff that we've already seen. Now let's get to the new stuff. So how do we represent a point? Notice that a point isn't just a single value. It's got two values. So how are we going to write this down? Because clearly the point x comma y is not a member of the set R. Right? If we were just pulling members from, if we were just pulling out a real number, it'd be one real number. So how do we represent something where we want to say that there are two distinct values? The first value is from R and the second value is from R. Well, we write it like this. And on the right, there's the graph that goes with it. So you write R cross R. And what that tells you is that you're going to have two values. The first one is going to be from the set R, and the second one's going to be from the set R. But this R cross R is a new, think of it as a megaset. So R cross R is just one set. It's created using these other sets, but it's one set. So x comma y is now one element, in the same way that it represents one point. Say you had the point 2 comma 3, that represents one point. Well, if we apply this notion, if we think of this in terms of set theory, as we've been using set theory, it's one element. Graphically, it's one point in the plane, and in terms of set theory, it's one element of the set R cross R. So that's the most common example that we'd see. Now let me make a basic abstract example. Suppose the set A is ABC, and the set B is 1, 2, 3. So we've got a new set that is A cross B. And I want you to tell me one element of that set. Yeah. A1. Yes. To be precise, A comma 1, but yes. Okay, so can someone else name another element of that set? B comma 2? Right. And C1, absolutely. Every possible combination, exactly. So the question is then, how many elements does this give you? I heard a couple people say it. This gives you 9 different elements. Uh-huh. Okay. So A can get paired with 1, 2, 3, B goes to 1, 2, 3, and C goes to 1, 2, 3. So 9 elements. So we can write that down. Okay, so we said that. So we can write that down in, again, set notation as we've seen before. So remember, that's the notation for how many elements are in the set. It's just n of that thing. And so mathematically, a really easy way to figure this out, n of A is 3, n of B is 3, so A cross B, n of A cross B is just going to be 3 times 3, because it's every possible pair. Okay. Now, is the element 2 comma A, is that an element of A cross B? Just flip it around, exactly. So the question is, if you just flip it around, is that the same thing or is that a different thing? Let me put it this way. Is the point, let me put it in terms of an example that you might understand. Is 2 comma 5 the same as 5 comma 2? Okay. So is this element in A cross B? No. Flipping it around is a different element, is a different thing. Okay. So, order matters. So if you write A cross B, that's different from B cross A as a set. And again, just think of the basic example, 2 comma 5 is different from 5 comma 2. Okay. So that was a quick introduction into the basics of the Cartesian product, also just known as cross. Any questions about this? You ready for the next thing? Okay.